So very simple. Hash table is nothing but a special kind of data structure which is useful for especially for searching operation. If you want to perform any searching operation, the best suitable data structure is nothing but what? Hash table. Let me have introduction to this. See, in the case of searching algorithms, in the case of searching algorithms, if you see, what is the main purpose of searching algorithm? We are going to take one object and we are going to search in the list of objects, right? So consider a problem we are searching for. Okay, we are searching for an object, so for an object in 100 objects, in 100 objects. Okay, so here how you are going to do? So if the objects are not, if the objects are not in sorted order, then we will search. Okay, we will search for the object, so continuously, one by one, one by one. This method is called as linear search. So which takes how much complexity? Big O of n. If you have n elements, then so if the objects are arranged in a sorting order, in a sorting order, then then we can search for the object, we can search for the given object, we can search for the given object. So by using binary search method, binary search method almost by reducing the number of comparisons. Okay, by reducing the number of comparisons. Sir, do you know, in this case the time complexity, the complexity of this algorithm is big O of log n, right? This is nothing but what we know. But there is one efficient searching algorithm is there for searching for any data, which is going to take almost unit time. So it is possible to get the location of a given key. So by using some magic methods or magic functions, we can able to search. Okay, so it's a time complexity it's a time complexity is big O of 1. I can say that is nothing but that is constant time. It is going to take a constant time. So that algorithm is nothing but what? Hash table. Hash table is the best data structure which is specifically used for search operation. Okay, so let me talk about the introduction to the hash table, like what is mean by this hash table, how you are representing. So very simple. Hash table. Hash table is a data structure. Hash table is a data structure. Data structure. Okay. That maps keys to values. We will be having some keys and we are going to map with the values. That concept is nothing but what? A hash table. So each position of the hash table is called as, okay, each position in the cache table is called as a slot or a bucket or a record, any word we can use. So example, if you want to see diagrammatic representation, so a hash table will be in this format, sir. A hash table will be in this format. Assume I'm taking a hash table which is going to take 10 elements, 0th location and the first location, next and after that the second location, next and after that the third location, so fourth location, okay, fifth location, so next and after that the sixth location, next and after that the seventh location, next and after that eighth location, ninth location, like this. So almost this hash table size is nothing but what? It can able to hold 10 objects. Can I say 0th location, first location, second, third, fourth, so fifth, sixth, seventh, eighth, ninth, like this. The total size of the hash table is nothing but a 10 based on your requirement. So each position in the table is called as a slot, this is one slot, this is one record, or this is one bucket, like that we have. So whenever we are trying to insert an object, we are going to write one beautiful function. Okay, we are going to write one beautiful function. That function is nothing but what? Hash function. We are going to write a hash function. We will send data to that hash function. Suppose assume the data which I want to insert is 13. This hash function is going to return the position where you need to insert it. Sir, this hash function is going to tell in third location I have to insert this 13. So identify the third location, here it will insert 13. Assume next time I'm giving another value for this hash function, which is nothing but 55, and it is going to return the location 5. Sir, here in 55 should be stored in fifth location. So direct access will be there even if I want to search for 55. So if you give I want to search for 55, what hash key it is going to return? 5. So directly you can check in the fifth location that object will be available. Sir, such a type of tool is nothing but hash function. Next, sir, here hash table. Okay, hash table uses hash function to calculate. Okay, to calculate the position or location of the object where you have to place. And how to do this? The process. Okay, the process of storing data using hash function, using hash function in the hash table, is as follows. Sir, what steps we have to take? The first step, we have to create an array of size n. That means maybe you can consider a list. So this list is called as a hash table. This list is called as what? A hash table. Then we have to find the hash code. We have to find the hash code of the given object. Okay, by using which function? Hash function. How to implement? We will see. So for that, a small technique is there. Take modulo division. Okay, take modulo division of the given object with the table size, so that we will get a hash function. To get a hash function, now in this example you can see, if you take the object called 13, so what is the table size? 10 elements. So 13 percentage 10, is it returning 3 or not? Yes, that's why we pushed that element into the third location. If you take 55 percentage 10, what output we got? 5. So that's why we pushed it here. Don't worry at all, this is nothing but what we have. So what is the next one? Finally, we have to store this object in the position which is returned by hash function. This hash function is going to return that, right? So wherever it is returned in that position, we have to store. So other than that, nothing. This is nothing but what we have about a hash table. And coming to the operations, sir, what operations we can apply on these? As usual, in the same case, whatever we have performed, we can perform this in these data structures also. What operations we are going to do? Sir, we are going to see insertion of the object, then we can see deletion of the object, then we can see displaying the elements present in the object, then even we can perform search operation. These are nothing but what are the operations that we can able to perform on data structures. So hope you people got very clear clarity, right? So any doubts up to this, whatever I covered, please confirm. Is the theory part, is it clear?
Clear, sir.
Yes, sir.
Yeah, but you can see there is some problem. I have a question for you people. Consider I want to store one object with the content 75. Can you tell me, according to our hash function, what value it will return? Can you please confirm? What is the hash key for that? Hash code for that?
7.5.
75. 75. Which hash code it is going to return? 5, right? But in the fifth location, already element is there. How you can store? So whenever collision, this is called as a collision. That means if you are giving any object, so it is hash code is going to return some hash function is going to return some hash code in that location. If already some object is available, then that technique is called as what? Collision. If a collision is coming, how we can able to solve that part we will see later. Okay, as of now I want to implement this hash table. Basic fundamental implementation of a hash table. Hash table we have to see. Let us see how I am going to implement. It is a very simple. I am taking a small Python program. Have a look once. So in this Python program, just I want to take hash table. I am taking hash table. In this, so we are going to write a constructor underscore underscore init underscore underscore, which is taking self and then size of the hash table. Then, sir, do you know self dot size is equal to, I am giving size of the whatever value that you have given, and I am taking a list with self dot. What is the list here? I'm going to take all the elements as a minus 1 into, sir, what is the size that you have given? Suppose if you have given hash table, okay, with the size 10, then all the elements by default it will be there minus 1. Then I'm going to write a print function, so which is going to print all the elements. So here I'm going to print the message saying, so hash table content is nothing but what? So for each I value in the range of self dot size, how many elements are there? Those many times I'm going to print in a formatted string saying, okay. So first it will print the location and the corresponding element. What is that element? Where it is available? So that element is available. Can I say, is it in L of I? Yes. Like that we are going to print. So this is a simple function whatever I have given. Now hash table is equal to, I am creating a new hash table. What is the size? Let it be 10. 10. Hash table dot I am calling print function. Okay. Now let us execute this code and check what will be the result you are going to get. So py space test dot py I am giving. As you can see, L is not defined. 1 second. We have to take self.l because we are in object oriented principle concept we are using. That's why it is like this. Now you can see I have a hash table. What are the elements present in the hash table initially? So it is having all minus 1 values. I think the basic functionality is clear for it. Now I want to add an object. If you want to add an object, we have to write a function. What is that function? Is nothing but a compute. Any name you can take, just I'm taking compute. So which is going to take one value, sir. One value it is going to take, and it will return. So the position where you need to store that value. How to do that? Can I take value percentage, size of the table? Yes, it is going to return the index value. In that place, we have to add. I am taking add function, which is going to take the value which you want to insert. Sir, first, what we have to do? We need to identify the hash code. How to identify the hash code? Can I call compute function by passing the value which you want to insert? So it will return hash code. Now I will check. So inside the list, is that a hash code position? Is it empty or not? Is that a hash code position? How to check is it empty or not? If it is not equal to minus 1, no problem. In that element, okay, in that position, you can store the value whatever you required, and please return true saying that element got inserted. Otherwise, what we are going to see, we are going to return an element is not inserted. Simple operation. So we are going to pass some value. In this example, we passed 13. So what my hash code is going to do? For 13, it will return the hash code. What is the hash code for 13? It is a 3. So in third location, I am going to check. Is it not equal to minus 1? Previously, it is not equal to minus 1. Then store the value and return the message saying true that element got inserted. Now I am inserting 55. So 55 also, it will check fifth location. Since the fifth location is a true, it will store the value and it will return true. Let me cross check. So I am calling hash dot add of 13, and I am taking, so print of h dot add of 55. Is these two objects will be inserted or not? Let me cross check. Sir, we are getting false, false. Something is wrong. Is not equal to minus 1. Is equal to minus 1, then we have to store, right? Now have a look once. Both objects are returning true. So in 13th location, sorry, in third location, 13 got inserted. In fifth location, 55 got inserted. So there is a one problem is there. Suppose consider I want to insert 99. Okay, I want to insert 78. So where these objects will be inserted, we know all these objects are going to be inserted. These are the positions what we have. Now consider I'm trying to add 53. Is it going to be added? No, definitely it will return false, because for 53 hash code is nothing but what, 3. But in that location already some object is there. I can't able to insert. Like that add function is going to do. Now same thing I want to implement for delete. How to delete? Very simple. Just we have to take a value which you want to delete. As usual, you have to find out a hash code for that value, whatever you have, and you will get that hash code. So we need to check. So in that particular hash code content, okay, is not equal to minus 1. It should not be equal to minus 1 at the same time. So self dot that list hash code is there, right? There your content should be there. So if both are true, then please make that hash code content is equal to minus 1 and return true, saying the deletion success. If it is not equal to, I mean, if the content is minus 1, that means in that position element is not there. Simply can we return false or not? Yes, like this we have. So let us cross check. So here just I am calling h dot delete of something like so 56 I am deleting. Sir, is it possible to delete 56? No, it will pass 56. Hash code is 6. So L of 6, is it not equal to minus 1? No, it is equal to minus 1. So come out from the if condition, return false. Now consider I want to delete 55. So what will happen? So it is going to return hash code for that. So hash code is nothing but what, we will get 5. So in that fifth location, is it not equal to minus 1? Yes, it is not equal to minus 1. And is it 55? Yes, both the conditions are satisfied, means reset that value and return true. So after this, can I print the value of hash table? Yes. Let me cross check. Invalid syntax. Array, sorry, I have used the double and symbol. We have to take the word called and. Now you can see, sir, hash table, this one got deleted and 56 is not deleted. So 55 is there previously, now 55 is removed. This is the way how you can perform delete operation. What about the searching? def, I am taking search operation. Which object you need to search? Anyway, first we have to find out hash code for this. We have to find out hash code for this. So then directly we are checking inside the list, in that particular hash code location, if the content whatever you have given, is it available, means return true. So otherwise we can return false. So is it going to take any loop? No. If I want to search for a data, is it going to take any loop? No. Immediately it is going to return false. So this is the way how we can able to work with this hash table. Anyway, delete function I explained. Now let us search. So I'm going to call search function by passing 13. Since 13 is available, it will return true. Now I am passing the element like something like 55. Just now we deleted this, right? So immediately it is going to return false. For last two answers, true and then false. This is nothing but the normal implementation of a hash table what we have. So hope you people got very clear clarity. Any doubt in this hash table program, sir? Can you please confirm?
No, sir.
Right. Sir, what about remaining? Please confirm. Clear up to this.
Clear, sir.
Right. So now I told there is a problem with this hash table. What is that a problem? Collision. Collision will occur. Sir, when a function generates the same index or the same hash code for two or more objects, so then it is a very difficult, to store that value or to store that object into the hash table, into the hash table. So in such a cases, so collision will occur. Collision, collision will occur. It is going to generate collision will occur. Okay. So this is nothing but what we have. But we have to write. Okay. So we have to write a function. We have to write a hash function efficiently, efficiently without collision, without without collision, without a collision. So but practically it is impossible, practically it is impossible. So that's why we have some collision, okay, some collision resolution methods are there, collision resolution methods are there. So what are those methods is nothing but one is linear probing, and the second one is quadratic probing, and the third one is separate chaining, separate chaining. Like this we have three techniques are there. By using these three techniques we can able to avoid the collisions in the hash table. I think the concept is clear for you. If theory is clear for you people, I will go to implement the program one by one. Clear?
Yes, sir.
Yes, sir.
Right. So just a second, I will continue. Just give me 1 minute a time, sir. Yeah, let us continue. So now the next concept is linear probing. See how you are going to solve this particular collision in the linear probing. Sir, for this I'm going to take one worst case scenario, like 3, 13, 23, 33, so 43, 53, 63. Like this I'm going to insert. Okay, because you can see there is a problem, right? When you are trying to insert 3, where it is going to insert? Forget about all these things. I think you know very well where that 3 is going to be inserted. Have a look once. First we are giving the value 3, so 3 percentage 10, immediately it generated 3. So in third location that 3 will be inserted. Up to this, okay. Next element is what? 13. 13 percentage 10. What result we are going to get? 3 only. But 3 is already filled. Then what we have to do? We need to apply some collision method here, collision resolution method. What is that method? Linear problem. How we are going to do in the linear problem, sir? Sir, everything is the same except the compute function. Already we have compute function is there, right? We will take another compute function like compute one I am taking. So self comma, if you are taking any value, okay, if you are taking any value, or maybe it is nothing but index. If it is taking any index, it will return the same index. It will return the same index. This is called as linear problem. And see how I am going to apply that. In the add method, first I will calculate a hash code by using normal compute only. Okay, and I am going to check. I will take a loop for each I value in the range of self dot size. So how much size your hash table is going to have, those many times it is going to run. Every time I will check, is that self dot l of hash code whatever you generated, is it equal to -1? If it is equal to -1, then what is the meaning? You can place that value, right? So l of in that particular location, directly we can place the value and we can return true, saying that element is inserted. Now observe carefully. First time when we are taking 3, please listen, when we are taking 3, what is the hash code that we got generated? So self of we are passing that 3. So it is taking 3 and 3 percentage 10. It is going to return 3. We are checking in that third location. Do we have -1? Yes, previously we have -1. So hash code value is a 3. Immediately we are going to insert that element here. No issue at all. Now let us check. I want to insert 13. What hash code it is going to return? For hash code of this 13 is it will return 3. But you can check, is this L of 3 is equal to -1? No, sir. Already element is there. Then where we can insert? So come out from the if condition and check. Again, we are going to calculate a new updated hash code, which is nothing but already available hash code plus. So compute 1 by sending the value of I. Now what will happen? Sir, what is the I value initially? I value is initially 0. Okay, so now hash code plus I'm going to take 0. What is the value? 3 plus 0, it is going to return 3. Sir, in that third location already it is there. Now I value will be updated. Second time it will take, because it is a loop, right? Second time, so in that location, what is that hash code? 3 only. In that third location, do we have any space? No. Then hash code is equal to already available hash code plus I is equal to 1. It will check in the fourth location. Sir, is the fourth location is empty? Yes. If fourth location is empty, try to insert that value in the fourth location. Now I want to insert a 23. So first 23 is going to calculate hash code as a 3, but there is no vacancy. Then next time 3 plus 0, 3 plus 0, because I is equal to 0. Sir, we will get 3, not empty. Next time 3 plus 1, it is going to return 4. It is not empty. Next to 4 plus 1, it is going to return 5, because previous hash code plus 1. Sir, it is empty, right? So it will insert here. Okay, so then if I want to insert 33, first it will check in 3. It is not empty. Then 3 plus 0. So next value, is it next value is available? No, it is not available. 4, the vacancy is not there. 4 plus, next time we are going to check in 1. So 5, the vacancy is not available. So 5 plus next time it is going to generate to 7. Is the seventh location is empty? Yes. Like this, we are going to move linearly. We are searching and we will insert. Okay. Sir, once if 9 came, but we started inserting from here, but still rest of the locations are there. That's why for that I am going to update hash code with hash code plus, okay, hash code plus, sorry, hash code percentage self dot size. Do you know, to move this hash code in a circular manner, I have taken this. Okay, it will keep on moving. For example, in this example, it will start from I is equal to 3 to I is equal to 9. When I is equal to 10 came, what will happen? Again it is going to restart from the beginning. Like that, it will check how many times. What is the table size? 10. In these 10 locations, appropriate element it is going to find. Sir, this is nothing but what we have. Sir, what about the delete code? Sir, almost in the deletion also, same code we have to write. But if this condition is also failed, then sorry, I can't able to insert. In the deletion also, we will find out hash code and we will check. So self dot L of, so in that hash code, whatever we have in that hash code, whatever element that we have, is it equal to -1? At the same time, that element is matched. Then what we have to do, in that place, I am going to take -1 and then I will return true saying that element is available, deleted. Otherwise, I will calculate and I will keep on continuing. Like this we have. At last return false. So even for the search operation also, same thing we have to take. So what is that operation? Sir, we will check whether the element is not equal to, sorry, we will check is that element is matched with that key value. If it is true, then we have to return true. Otherwise, we need to check in the remaining areas. That's all, sir. Linearly, we are checking. But here still the problem is there. What is that problem that we will see later? Let me insert a first time I'm inserting 3, then 13, then 23. Let me check is these 3 objects got inserted or not. So compute 1 somewhere, that is we have to take a self dot compute. So every time wherever compute 1 is there, we have to take self dot compute 1. Now you can see, sir, 3 got inserted, 13. Have you observed? Immediately it is a find out the next location and it is a stored. Then next one is also stored. Like that we are having. So next I want to insert 33. I want to insert 33. Next I want to insert 43. Let me check, is it inserted? Because still it is going to raise some problems. Let me check. Yes, up to 43 it is inserted. Now try to insert 53. Yes, 53 is also inserted. Let me insert a 63. Have you observed? Even though there are some vacant positions, it is unable to insert 63. Why? Because let me check. So what is the initial value of I? I value is equal to 0. First term, it will calculate a hash code. What is the hash code? What is the object that we are trying to insert? 63. 63 percentage 3 means we will get a 3. In third location, already element is there. Then what will happen? So next time, it is going to take, so hash code is equal to, so already available hash code plus 0, which will return 3. So 3 percentage 3 means, sorry, 3 percentage 10 means we will get 3 only. Updated hash code is 3. Then next time it will check for 1. What is the hash code? So previous hash code is nothing but 3 plus 1, which is equal to 4. So updated hash code is 4 percentage. Okay, 4 percentage. What is that value that you are going to get? 10, which is nothing but 4. Is the fourth location is empty? No. Then I is equal to 2. So then what will happen? So 4 plus 2, which is nothing but 6. Sixth one is also filled. Then I is equal to 3 means 6 plus 3, ninth location. Sir, it is also filled. Then I is equal to, so what is the previous value? 9 plus, what is I value? 4. Sir, which is nothing but 13. 13 percentage 10. Because it is going to take percentage 10, same value we will get 3. Sir, third location is again filled. So next I is equal to 5. So previous value is a 3. 3 plus 5, 8. 8 percentage 10 means we will get 8 on. It is also filled. Now for 6, so 8 plus 6, 14. 14 percentage 10 means we will get 4. This is also filled. Now 7. So what will happen? 4 plus 7, 11. 11 percentage 10. Sir, what is the output that we are going to get? It is also filled. 8 means what? 1 plus 8. That is nothing but 9. 9 percentage 10, 9. So it is also filled. Now take 9 next value. Sir, 9 plus 9, which is nothing but 18. 18 percentage 10 means 8. This value is also filled. So total table we have extracted, but there is no place. Like that we are going to get. But still vacant positions are there. That means the program is correct. but my linear probing is not generating a proper hash code values. That is nothing but what we have. Are you clear with this case? Please confirm. Clear up to this, whatever I covered, please confirm.
Yes, sir.
Right. So this is nothing but what is linear probing, what we have. So to overcome this problem, we have to go for next one. What is the next one here? Quadratic probing. Quadratic probing. In the quadratic probing, we are going to update the formula, sir. So what is the formula that we are going to update is, so we are not checking in a linear fashion, just this compute to function is there, right? That we will update. What is that a compute function is, I am going to take another function like a compute to, so which is going to take one index value. Instead of searching in a linear manner, it is going to search in quadratic manner. Sir, can I take index into index? Yes. So this is called as what? Quadratic probing. Now see what will happen. Wherever compute one you are taking, that you have to replace with the compute. Okay. So now try to change the values. So I want to, this one is also having some issue. Okay. Let me cross check. Sir, I want to insert a 5, next 15, next 25. Let me check is these values got inserted or not. Yes. Now I want to insert 35. Let me check is it inserted or not. Yes, it is inserted. Let me check 45. It is not inserted. Still here also we have a problem. Okay. So how it is working, just you can trace it how I explained in the same style it is going to take. Okay. So but instead of checking in a continuous manner, we are going to update the value of I. So here also there will be some issues. To overcome this problem, at last we are going for which concept? Separate chaining. In this separate chaining, we will maintain a linked list. We will maintain a linked list. For example, if the node 3 came, so here we are going to index, we are going to attach all the nodes which are ending with 3 like that. Let us see the implementation. It is somewhat complex. So hash table is there. So here we are going to take a list. Yes, we can take a list here as it is. Now, sir, we need to take another class to represent a linked list. That class is nothing but what? Node class. Inside this, I am taking a constructor which is going to take two fields. One is nothing but the values. Another one is nothing but next field. Self dot value is equal to, it is going to take value. Self dot next field is nothing but whatever next that you have assigned. If you are not giving any value, it will be always none. This is node. Now what will happen inside the constructor? So what kind of values it is going to take? So maybe you can take -1 or it can take the node values. What is the default value for node? Can I take, is it a none? Yes, none values will be there. So while printing, I'm going to print the hash table content. So how to print hash table content? Print of hash table content for each I value in the 0 to self dot size. So F, but here we can't print this directly. Okay, we can't print because linked list, right? So you need to take end is equal to space, and here we have to write a code to print the data present in the linked list. How to print? So we have to take temp is equal to self dot L of I. First node we are going to capture. So until your temp is not equal to none, you have to keep on print the value called temp dot value and separated by some space, or better to give arrow mark. So next, what is the value of temp? Temp is equal to temp dot next, because in the linked list we have seen very clearly how you can able to trace out. So let me call only print function. Let me call only print function. So is that linked list is there or not? Let me cross check. You can see linked list is there. So for 0th location, none is there. Now I want to add. So we are not required to take any return type because we know we can give guarantee for the element. I want to add 3. So coming to the add function, it is going to take the value as a 3. Okay. So what modifications we have to do? So we are not required to calculate a hash code. I mean, this linear probing, quadratic probing is not required. So directly I'm going to find out the hash code for the given value, and directly we can insert. How to insert? Very simple. Self dot L of that hash code is there, right? For that, I'm going to create a new node. For that, I'm going to create a new node with the given value. What about the next field? Next field is nothing but so that hash code value. Like this, I'm adding. Now, see, is that 3 is added or not? You can see that 3 got added. Now I am adding 13. Where it will be added? The same thing, but a continuation list will be there. Sir, I want to add 23. Where it will be added? In the same position. Like this, we are maintaining a link, sir. So what about other objects? Other objects also will be stored, no problem at all. For example, 34, so 77, something like 29. Okay, next and after that 22. Okay, next and after that, so 23, 20, 33. Okay, so next I'm going to take 43. Next I'm going to take 53. All the numbers which are ending with the 3 will be attached here. Rest of the nodes will be available. Is there any chance of collision here? Never. This is nothing but what we have. Sir, what about to delete? If I want to delete any node, what we have to do? So hash code is there and we are not required to write any loop. So we have to check. I'm going to take a temp is equal to, so self dot, okay, self dot list of what is the hash code it is generated that we are going to point. Suppose if I want to delete 23. So my list is pointing to the first element where it is available. Then what we have to do? We need to check is your temp is not equal to none. At the same time, that a temporary node value is nothing but the value what you have given. If this condition is satisfied, then we have to delete this node only. Then simply I am going to return through saying that element got deleted. And what we can do? So self dot list of that hash code is there, right? Okay, that I am going to take it as a temp dot next. Just next node we are attaching. That's all. Automatically it will be deleted. Let me cross check. In this hash h dot, so delete off that hash table dot delete off. Which node I am trying to delete? 23. After that, try to print hash table. Let us check is the 23 got deleted. So return type is none. I think here after this we have to return false. Sir, it is returning false that 23 is unable to delete. So what is the problem? Hash code is equal to self dot compute of that value we are passing. Which item you want to delete? 23. It is there in the list. So it will return a hash code that is available in H code. So I am taking temp is equal to L of that hash code. And if temp is not equal to none and the temp dot value is equal to value, A of hash code is equal to temp dot next. Suppose if this condition is not satisfied, that means still it is available in somewhere else. So temp is not equal to none. We have to take a next node. Next node means let me take current node. Otherwise, temp one. I'm going to take a temp one is equal to temp dot next. So again I will check. So is that temp one is not equal to none at the same time. So that temp one dot next field or temp one dot value field is equal to the value which you want to delete. Then what we are doing? So temp dot next field will become, so temp one dot next field. At last we have to return true. So I will explain what is this. See, when you want to delete 23, so which one will become temp one beginningly? So this 3 is nothing but first element present in this is nothing but temp. Now, is it not equal to none? Yes, it is not equal to none. Is it equal to your data? No. So that's why we have written only this code for the first element, delete at first. So otherwise what we are doing, this will become your temporary node. Temporary node is not equal to none. That's why we are taking another temporary node which is pointing to 43. Is 43 is not equal to none? Yes. and 43 dot value is equal to 23. No, then temp dot next will become temp1 dot next. So this will become temp1 dot next. This will become what? Temp dot next. Then, so I mean, if the element is available, if the element is not available, then what we have to do? So we have to take temp is equal to temp1. Now this one will become temp. Now this one will become temp, like that till this particular node we are going to get. Like this we are deleting. Now let us see, is the 23 got deleted? True. Have you observed previously 43, 33? So in between 33 and 13 we have 23. But now 13 and 30, 33, in between the 23 is not there, automatically it is removed. This is nothing but how you can able to delete. So what about a search operation? It is something like a linked list search. How to search? We are going to take one temporary pointer which is always pointing to the first node, whatever hash code it is returning, and until your temp is not equal to none, you are going to check whether your temporary node value is equal to the value which you are searching. If it is true, then return true. Otherwise, search for the continuation manner. So if anywhere that element is not there, at last I will return false. That's all. Now if you want, let us call search operation. I want to search for 13. I want to perform search operation for 13, and I want to perform search operation for 23. 23 recently deleted, right? That's why it is returning false. But 13 is there, right? It will return true. This is nothing but the separate chaining what we have. Are you clear with this linked list implementation of this hash table? Please confirm. Clear?
Yes, sir. Sir, if we are adding 22 in index 3 and outside of the index 3, I mean, same value if you are inserting two times means how we are going to search and delete the element value.
Uh, I think it is going to take in a continuation manner, sir. Probably you should not take duplicates. Suppose if
So,
duplicate
unit.
here, anyway, it will return that value. But while deleting search operation, won't, sir, 1 second, please wait. Hello, hello. Uh, no problem. And for search operation also, there is no problem, right? Because in inserting 22, after that 22 will be there. For search operation, anyway, this object is there, it will return true. Okay. So whereas coming to the delete, there will be an issue. But if you see delete operation, it will delete only first occurrence. And please make sure that it is related to the something like hashing. In the hashing, duplicates are not allowed. Okay.
Okay, sir.
Yeah. So when you have to take, just for your understanding purpose, I am telling like this. But strictly speaking, so you have to take a proper value and you have to insert like a student ID. Okay. Next, and after that, mobile numbers. Such type of data you have to consider as a key values to insert the data. Okay.
Yes, sir. So, like it's like a duplicates removal, like that I'm asking, sir.
Duplicate removal. Yeah, you can do
Yeah,
that.
yeah.
Already in the linked list we have seen, right?
Yes, sir.
We can remove. It is
Oh,
same like a linked list. Whatever operation I told here, all these things are linked list only. You
yes,
can
sir.
do. Okay.
Okay, sir.
Yeah, right. So with this, I'm going to stop today's session. So with this hash table data structure is over. Then bit manipulation is there, that I will take on next class. Okay. So probably, yeah, tree data structure got completed, sir. Tree data structure got already over because we have seen tree, binary search tree, AVL tree we completed. Okay. So maybe tomorrow I am going to take the session. I will inform you the timings. So I will finish this graph data structure tomorrow and the day after tomorrow. Okay. And then bit manipulations, dynamic programming, greedy algorithms, these priority queues will be covered in the next week. Maximum next week I will wind up. Okay. Right, sir. I will upload the running notes within few minutes. You can download.
Okay. Thank you, sir.